Welcome back, students. We're going to be learning about confidence intervals today. This will be Module 4, Lesson 1, Introduction to Confidence Intervals and a confidence interval for a population proportion. You can find this on page 102 of your notes. Let's begin. Think about a weather forecast. And the meteorologist might say, there's a certain chance that the temperature might be in this temperature range. Well, they're never going to say 100 because they can't be 100% confident anything's going to happen. But they can set a reasonable level of how confident they are. So today we're going to be modeling how to set that reasonable level and how to make an estimate in both directions, above and below what your prediction is. You've probably been asked before to guess how many beads are in a jar or candies are in a jar or something like that. In our class, we'll do some sort of activity related to that. Can't really do that in a video, so let's go ahead and talk about what a confidence interval is and how to interpret it. A confidence interval gives a set of like plausible values for a parameter based on a sample data. So if I collect some data and get like the percent of blue beads in a jar, you might say 50%. But you could have a little margin of error. Maybe it's 5%. So it could be anywhere between 45 and 55%. So when we interpret that confidence interval, we might say we are 95% confident that the interval from 45% to 55% captures the true proportion of blue beads in a jar. As far as that level goes, what that means is if we were to keep making a bunch of confidence intervals, approximately what percent of those intervals will capture the true proportion of the blue beads in the jar, for example. So the interpretation goes, if we were to select many random samples of the same size from the same population and construct a 95% confidence interval, for example, using each sample, about 95% of those intervals will capture the true proportion of blue beads in the jar. Now, it doesn't really make sense to look at those interpretations until you see what we're working with here. So we're going to go to a little activity here. Go ahead and pause the screen, read through those directions. I'm going to pull it up on my end, and I'll walk you through the questions and simulate how to work all these out. Okay, the directions are shrunk down a little bit to accommodate the website. If you have a hard time seeing it, I'll read through them. So the first thing we're going to do is we're going to go to Stapplet.com, and we're going to hit Simulating Confidence Intervals. So we'll click on that, and we're going to choose Categorical. We're dealing with proportions in this unit. So we'll do categorical, and we're going to keep our proportion of successes to, we'll say 0.6, so 60%. So for our population, our distribution would be 60% success, 40% failure. For part 3, we're going to make our sample size be 200. So we're going to do a large sample, and we're going to keep the default confidence level at 95%. So we'll hit go. Now, when I go down there, what I'm going to have is we're going to simulate one interval. So I basically have an interval between, in this case, 57.9% and 71.1%. You're going to notice that down here, you're going to see this vertical bar right at the population proportion of 60%. And you'll see that this interval captures that 60%. 57.9% is below it, whereas your higher end of your interval, 71.1%, is above it. So it's a hit. And if I kept doing that, and I click it 9 more times. 1, 2, 3, 4, 5, 6, 7, 8, 9. You'll notice that in this case, all of my intervals, you can see the total intervals capturing the population proportion was 100%. Now I can quickly select a bunch of intervals. So I'm gonna change that to 50 and I'm gonna hit go. And notice now that some of those intervals didn't capture it. Right? If you look at this one here, oh, that's a little bit too above. So is that one. And this one's a little bit too below. But most of them captured it. About 95% of my intervals were captured. And if I keep hitting go, and let me get that up to a little bit over 1,000, we'll say. So we'll just click that a bunch of times. Notice that out of my 1,010 intervals, about 94.2% of those intervals were capturing the true population proportion of 60%. And of course, I could make that ridiculously high. I could say like 1,000 there and just make it so much so that you're going to see that percent eventually level off to 95%. And that's always going to be the case. Whatever my confidence level is set at, the proportion of intervals that are going to be capturing the true proportion is going to be 95, whatever that confidence level is. So I set it at 95%. But if I go over here and make it, let's say, a 99%, let me click enter here. You're now going to notice that the intervals got a little bit wider. And as a result, a higher percent of those intervals are capturing the true proportion. What percent? 99%. 98.8% will round to 99. And you can see that that 99% interval got wider. Now, what happens when I go low? I make it 80%. Look, there's a lot more red here. So, in fact, about 80% of those intervals are captured using this process. So the confidence level has a direct relationship with what percent of the intervals that you do capture the true proportion. So take a look at that last question here. What is the relationship between the confidence level and the capture rate? Well, if you hadn't noticed, the confidence level is equal to the capture rate. So the percent of intervals that are going to be captured is really just whatever you set it to be. Let's look at an example. The National Health and Nutrition Examination Survey is an ongoing research program conducted by the National Center for Health Statistics. Based on a random sample of 500 U.S. residents aged 8 or older, a 95% confidence interval for the mean systolic blood pressure, the upper number in the blood pressure measurement, is 119.6 to 123.6 millimeters of mercury, mmHg. So we have a few questions here. Interpret the confidence interval. Part B is going to be asking us to make some context with it, so we'll explain that a little bit later. Part C is interpreting the confidence level. Part D is calculating a point estimate and margin of error for this estimate. And Part E is expressing this in a different form. So let's talk about that first part first. When we're interpreting a confidence interval, we want to follow this interpretation down here. We are a certain percent confident. So whatever our percent level is based off of the confidence level. So 95% confident that the interval from this number to this number captures the true parameter in context. So in this problem here, what are we talking about? We're talking about systolic blood pressure. So we have a 95% confidence rate. So what we're going to do on the interpretation is you're going to write this down. We are blank percent confident. We're going to write 95% that the interval from. Now, as far as getting those intervals, we're going to look at the numbers here. Our low point of our interval is going to be 119.6. Now we want to put a unit on there, so it's going to be mmHg. So I'll squeeze that over here. And then our high end of your interval is 123.6. And again, mmHg, millimeters of mercury. Captures the true. And then from that part, we just go back to the context of the problem. So we're going to look for what we're looking for. So mean systolic blood pressure is what we're looking for. So mean systolic blood pressure is what we're going to write. You might notice that I wrote of U.S. residents age 8 and older, so I put the full context below, but mean systolic blood pressure in this case would be probably perfectly acceptable, so I'm okay with that. Part B, according to the Center for Disease Control and Prevention, normal systolic blood pressure is less than or equal to 120 millimeters per mercury. Based on this interval, is there convincing evidence that the mean systolic blood pressure of all U.S. residents age 8 and older is greater than 120 millimeters mercury? Explain your reasoning. In this problem here, we want to look at the interval itself. You might notice that 120 millimeters per mercury is actually between 119.6 and 123.6. So to answer the question, do we have convincing evidence that the mean is greater than 120? Well, the answer is going to be no, because we haven't proven that it's greater. We only show that it's between those two. How would we write that? I would say since 120 millimeters per mercury is between 119.6 and 123.6, we do not have convincing evidence that the mean is greater than 120. If the entire interval were below 120, then we would. Part C. Interpret the confidence level. This is the one a lot of people struggle with. And so think back to the activity we did when we were capturing many, many, many intervals. The way that you want to interpret that is going to usually be the same, and there's not a lot of variation in how you write it. So the way you say it is, if we were to select many, many random samples of the same size from the same population and construct since we're still dealing with a 95% confidence interval, so we're going to write 95% confidence interval using each sample, about 95%. So we're going to repeat that number again. About 95% of those intervals would capture the true. And we're going to go back to what we're talking about. So mean systolic blood pressure. And if you want to get technical of, US residents age 8 and older, but that's what that interval is. So again, if we were to select many, many random samples, construct many, many 95% confidence intervals, about 95% of those intervals would capture the true parameter that we're trying to measure, mean, proportion, whatever it is. Part D, calculate the point estimate and the margin of error for this estimate. So let's go back to the interval. We have 119.6 and 123.6. The point estimate is the midpoint, right in the middle. We get that by averaging these two numbers together. So what we'll do is we'll take the 119.6, we're going to add the 123.6, and then we're going to divide that number by 2. So that point estimate is going to be 119.6 plus 123.6 divided by 2. Use your calculator if you need to. That'll give you 121.6. The margin of error is half the difference. So it's like the overall difference cut in half because remember you can go above and below that estimate. So you get that by subtracting them and dividing by 2. This ends up being a nice number. You'll get 2. So your margin of error is going to be 2. 2 millimeters of mercury. So we kind of put that together. So a confidence interval is basically your point estimate plus or minus your margin of error. Let's label these first. So we have our point estimate plus or minus your margin of error. And the way you write your additional way of writing this interval is basically just that. You're going to take your point estimate. So that's going to be 121.6 plus or minus 2. Let's look at how that works in the calculator. So if you do 121.6 and subtract 2, you'll get your low end, 119.6. And then if you do 121.6 plus 2, you're going to get your high end. So 123.6. Okay, so the check your understanding, you might want to pause this and try it on your own. I'm going to go over this in 3, 2, 1. The Pew Research Center and Smithsonian Magazine recently quizzed a random sample of 1,006 U.S. adults on their knowledge of science. One of the questions asked, which gas makes up the most of the Earth's atmosphere? Hydrogen, nitrogen, carbon dioxide, or oxygen? A 95% confidence interval for the proportion who would correctly answer nitrogen is 0.175 and 0.225. So we want to do the same questions as before, interpret the confidence interval, the level, ask a context question, and get the point estimate margin of error, and then write this a different way. So if you think you want to go back to how we did it before and try this on your own, be a nice time to pause the video. And we're going to go over it. So for that first part, remember for the interpretation of the confidence interval, we always want to kind of follow this rule. We are blank percent confident that the interval from this to this captures the true parameter in context. So what is that going to look like here? Well, we were 95% confident that the interval from 0.175 to 0.225 captures the true proportion who correctly answered nitrogen. And I did put in parentheses as the gas that makes up the most of the Earth's atmosphere because that is the full context. However, I think answering nitrogen at the end would be fine. What about the next part? Interpret the confidence level. Well, here's our blank interpretation statement. If we were to select many, many random samples of the same size from the same population and construct a blank percent confidence interval using each sample, about blank percent of the intervals would capture the true parameter and context. The parameter is going to be the same. Thing about this one is there's less variation in how you write it, so there's really less like new things you put in it. Notice that I repeated the confidence level, 95%, 95%, and I put my context proportion to answer nitrogen. I didn't put the full context. I didn't feel it was necessary again, but that's how you would do that problem. Part C. If people guess one of the four choices at random, about 25% should get the answer correct. Does this interval provide convincing evidence that fewer than 25% of all US adults would answer this question correctly? Explain your reasoning. Well, let's look at our interval again. Well, if our interval is from 0.175 to 0.225, so 17.5% to 22.5%, that 25% is going to be above the whole interval. So if I'm trying to say, do I have convincing evidence that fewer than 25%, since my entire interval is below 25%, what do you think? Well, the answer is going to be yes. Your justification would be related to the direction of the interval. Since the entire interval is below 25%, there is convincing evidence that fewer than 25% answer correctly. Part D, calculate the point estimate and margin of error, and then express the interval in a different way. So this part is just the number crunching. Your point estimate is going to be add them up, divide by 2. It's the midpoint of them. It's going to be your sample proportion in this case, since we're talking about proportions. So just add them up, divide by 2. And then your margin of error will be the difference divided by 2. And that'll get you 0.025 or 2.5%. And to put it together in a different way, you're going to take your point estimate and your margin of error. Just do a plus or minus between them. So your interval would be 0.2 plus or minus your margin of error, which is 0.025. And that concludes this portion of the video. I'm going to split this up over 2 videos. So the next video is going to talk about what conditions are required for calculating a confidence interval for a proportion specifically, what that point estimate and margin of error look like in terms of when we collect the data and how to calculate those. So we'll conclude that in the next video. Thanks for watching this one.